Hello friends, welcome back. I am Rajneesh and today in this episode we are going to understand shared storage with the help of iscsi protocol. So if we talk about clustering environment, we have multiple nodes that work together and they should have some common shared storage on which the data resides. For example, let's talk about a web cluster server. In case we are talking about high availability web cluster server, there should be a folder on which the website is residing, and the folder should have the same data on all the nodes that belong to a cluster. So how do we make it possible? In case we have different disks or different partitions on different servers, it will be difficult to sync the data. So what is the approach that is used in cluster is shared storage. That is, we can use or we can export a shared block device which will be accessible by any node that belongs to that cluster, so that we have a consistent data across all nodes in the cluster. So there are basically two ways that we can use or export a block device. First protocol that can be used is over the fiber channel. So we can use fiber channel SANs to connect to the servers or the nodes. And the second approach that we can use is iscsi protocol that works over the Ethernet. So we can use Ethernet cables or we can use switches to connect to the iscsi target, and effectively the SCSI commands are sent over the IP based network. If we are talking about fiber channel SAN, then that is very costly and we cannot afford that in our lab. But if we talk about iscsi servers that are working over gigabit Ethernet, they work fine. So let's understand. In iscsi, we have two applications. One is iscsi Target, which is also known as iscsi server. The other part is iscsi-initiators, that is your iscsi clients. So iscsi Target is responsible for exporting a block device, and initiators are responsible for importing that block device. So finally, Target exports a block device, initiator imports that block device, formats that, and that can make use of it. So whatever modification this Linux machine or a node does are modified actually on the iscsi target, or in the other words, it's actually a logical unit number or LUN which is exported. LUN has a backed device attached to it, so it could be a different LVM or a RAID or a different partition that is exported over a LUN. So finally we are modifying the data in a particular LUN, and that data is modified on the SCSI target. So in case node 2 wants to mount that partition, it will have the updated data that was updated by node 1. So effectively we are sharing a part of iscsi target which is known as a LUN. So a LUN is exported and we work on that part in the nodes. Okay, other part could be if we want to describe it in somewhat greater details, iscsi target is a server. In iscsi target, we can create multiple targets on the same server having different target IDs. For example, target ID 1, 2, 3, 4. We can have multiple targets. Corresponding to each target, we can have multiple LUNs attached to it. LUN is actually a backing store that is attached to it. So effectively it means that to a single target we can attach multiple hard disk or multiple block devices, and the security can be implemented on the iscsi target at the target level. So if we define a particular target, we can allow a particular network or a particular IP address or on the basis of credentials to have access to it. Moving on to the next slide. First, we should understand the kind of storage that are there. First is direct attached storage. If you talk about your servers and your desktops, you may have the hard disks attached directly to your server that's present inside its cabinet. So that is direct attached storage. It can be attached to the server using IDE interface, SCSI interface, or SATA interface. Network attached storage means it's using file based protocol to access a particular folder. For example, NFS server and CIFS. Network file server, common internet file system. So this is same as Samba protocol. So effectively what happens in both the cases is we have a server which is running NFS server and which have a particular folder that will be exported over NFS. The same happens over CIFS. There is a folder XYZ which is present on the CIFS server and that is exported using CIFS or using Samba service. So this folder is now imported by the client, whether it's NFS client for NFS server, for Samba client, Windows machine or Samba client. So effectively what is happening in NAS case is we are exporting a folder using a file based protocol. And the same folder is imported or mounted into the clients and clients effectively work on them. If you talk about SAN, it's actually the block device which is exported rather than a folder. So SAN is used storage area network. It is used in your clustered environments where you want to have a common shared storage that is shared by the nodes in the same cluster. So effectively a disk or a partition, its LVM, RAID or a file is exported via or as a LUN and that is imported by the iscsi initiator and that works on it. Iscsi Target server or iscsi Target is a package that we install for it. It's actually your iscsi server. So what is Iscuzzy Target? The first feature is you should have terabytes of hard disk on it. The reason being this is the server that is responsible for exporting disks or the block devices to the nodes or your servers. Secondly, it should have a package Iscuzzy Target utils installed on it. What actually it does is it has multiple targets, each having a unique ID, and within each target there could be one or more LUNs attached to it, and effectively every LUN has a backed device attached to it. Backed device is the actual device or the file which is exported and which will be visible to the iscsi initiator. So the backed device could be a disk, could be a disk partition. Disk means dev sdb, partition dev sdb1, LVM, a logical volume that you created. It could be a RAID or file just for testing purpose. It uses IceKisi protocol to interact with the clients. So it basically works over the Ethernet or IP network. Next part is about the security of iscsi protocol or SCSI target server. It provides security on the basis of IP/network. That is, if we want to allow a particular node or a network to have access to a particular target ID, we can allow a particular IP or a network to have access to it. Secondly, we can have a challenge authentication protocol or CHAP based authentication, so that the client is going to authenticate it itself, and after it has authenticated successfully, it can have the access to the block device. In case it has not authenticated, it won't be able to access that block device. Final is target authentication. It simply means bidirectional authentication. iscsi client or the initiator authenticates to iscsi target, and iscsi target authenticates against initiator. So it's bidirectional authentication. So how do we create an iscsi target? First thing is we install the package iscsi target utils. Second, we create a target. Within a target, we create LUNs, and to each LUN we attach a block device. And now, after the LUN has been added, back device is attached to it, it's ready. The final option is you allow it to be accessed by a particular IP network or by specific credentials. Now, coming on to the iscsi-initiator, it's the client application that needs to be installed on the cluster nodes that will be accessing the LUNs which are exported by iscsi target. So the client applications connect to the iscsi server, and what actually happens is it sends iscsi commands to the iscsi server over IP network. So generally what we do is, first of all, we do discovery over a particular IP address, that is, we check out a portal for the LUNs that it is exporting. Secondly, after we have a list of LUNs that is exported by a particular target, we can just log in into one. If we are able to log in into that LUN successfully, we will have a new block device in the node, and that block device is now ready to be used. We can log out to release that particular block device, or we can just delete in case we don't want that block device anymore. Now, coming on to the lab. To demonstrate this, we have two virtual machines. One is server and one is desk 8. So server is a server on which we are going to configure iscsi target utils, or we are going to create a iscsi target. So first of all, let's install the required packages. Iscsi target utils. My CD is not mounted. Okay, so let me have a look into the files that are installed by this particular package. rpm minus query list of files present inside the package. So the service associated with it is tgtd, etc init.d, tgtd restart if it's not working, and chkconfig tgtd on. So it has started the service iscsi target and it's switched on, so that after every reboot the service will be up. Now the configuration file that has all the targets present inside it, or all the LUNs present inside it, is etc tgt targets.conf. So right now there is only one line inside it which is uncommented, which is default driver, and say iscsi. All other are commented. So the first thing that we need to do is, let's have a look into the help corresponding to TGT Admin. TGT Admin is a command or the tool that is provided by iscsi target utils so that we can manage the iscsi target. And so if I use TGT Admin -s to show all the targets, so it displays there is no such target as of now. Okay, so the other command that it provides is TGT ADM, and this is the command that we generally use for management of iscsi targets. So --LLD, we need to specify the driver that we have to use. So this is going to be iscsi in all the cases in our environment. Second part is mode, which says we have to work in which mode. At the topmost level of a target of a iscsi target service, we have targets. We can have multiple targets inside it. Corresponding to every target, we have multiple LUNs present inside them. Okay, I'll show you the dump that will make a better picture to you. So let me move to /etc tgt targets.conf. Okay, let's have a look into this example. Here it says we have a target with this name. Okay, regarding this name, the name of the target has a proper format that starts with IQN iscsi qualified number, then followed by dot year dash month dot reverse of your name, and then the name with which you want to export that folder. So here it says which is the direct store attached to it, and in this way, here you see first target, here you see second target. In the same way, you can have multiple targets which can be present on the same server. Each target, for example, we consider about this, may have multiple backing stores attached to it. So here you see LUN 10, LUN 11. So you are attaching multiple LUNs inside the same target. So your one target can have multiple LUNs or a multiple disks attached to it. At the top level, we have targets. Okay, so if you talk about target, what can be the operations that we can perform on them? First thing is we can do --opshow, which will display you all the targets along with the LUNs inside them. Other operation could be to add a new target, which is --op operation new --tid id. So this creates a new target with the name that you specify over here. The other option could be to delete a target. Third option is to show the details of all the targets, to show the details of a particular target, operation update, name, parameter, update some parameter inside that particular target. Additionally, you can do a bind operation which specifies an access control list, like which initiator address or which initiator network should be allowed access to that particular target. Initiator name, which initiator should be allowed to have access to it. Okay, so unbind means we are just removing access for a particular initiator or a particular initiator name or IP address. After that, there is one more which is corresponding to logical unit. So inside a single target, you can have multiple disks or multiple logical units attached to it. The operation could be new, that you are adding a new logical unit to it. So you need to specify the target ID in which you want to attach it and the LUN ID. And finally the backing store, which is the block device. You can specify the backing device type. In the logical unit, you can do a deletion which says delete from target ID this LUN ID. Mode could be account, where you are going to create a new account, or a delete a new account. You can do an operation bind on an account so that it is bind to a particular target. So that particular target can be accessed by a user who authenticates against these credentials. And finally, unbind, that is remove the access of a particular user to a target. So that is it. So let's start with it. TGT ADM --LLD iscsi. So this is going to be iscsi in all of our examples. --mode is target. Means the first part that we have to do is let's have a look into what targets we have. Right now we do not have any targets. So under mode equal to target, we'll do --, operation equal to new. That is, we are going to add a new target. --, TID. Let's start with 1 --, target name. That is going to be IQN dot 2013 March dot so this is the format. IQN, year dash month, reverse of the name, and the name of the block device with which you want to export. So here what I am doing is I am creating a target ID 1 with this name. Now if I have a look into the target's status, I can see that one target is created with this name. And what's the status? It's using driver iscsi and it's ready to be used. You can see that LUN0 is already created, which is of type controller. So every time you create a new target, controller will be attached to it, but this doesn't have any block device yet attached to it. So the next part of ours is going to be to attach a logical unit to it. So --, mode logical unit --, TID. We want to attach it to target ID 1 --, for LUN it was I think it was LUN only. Logical unit --, LUN and backing store. Okay, let's have a look into the backing store first. Def sdb print d2 d1 print Okay, so is it being used by something? fdisk -l def sdb. So here I can see that dev sdb is now blank and doesn't have any partition inside it, so it's fine till now. Okay, so if I have a look into this target, this doesn't have yet have any learn attached to it. So I'm going to attach a learn to it. So TGT ADM minus minus LL Iscuzzy minus minus mode logical unit minus minus up new, because we are going to create a new logical unit. uh, okay, now this is going to be attached to target ID 1 and logical unit number is going to be 1, and finally there should be a disk attached to it, so that will be marked as backing store. So backing store will be dev as db. So with this command, what actually I have done, I have gone into the mode logical unit and added a new logical unit with ID 1 to target ID 1. So let me have a look into the show operation corresponding to this, and here I see that learn1 is attached to it, that has a backing store or the device dev sdb attached to it. Now this device dev sdb is ready to be exported to any cluster node or any node that wants to mount it using iscsi protocol. Till now we can see that account information is blank and ACL information is blank. It simply says that anyone can mount this logical unit, which is very unsafe. So first thing that we need to do is we need to implement ACL information. My IP address is 1.8. So TGT ADM iscsi iscsi minus minus mode target minus minus up bind target operation bind. Here I copy the two things. So to target ID 1 I attach or allow the initiator 192.168.1.8. So it simply means that now only 192.168.1.8 will be allowed to have access to this target ID, which is target ID 1. No other machine can have access to it. But if you want to have further security, providing the credentials, then we can add an account. Minus minus mode will be account. We are going to add a new user account. Username user1 minus minus password is password1. So by this command, what actually I have done is I have created an account. Okay, so up new. Okay, I created an account using this command. Now the second part that I need to do is I need to attach this account to the target ID 1. So minus minus mode account minus minus operation is bind I attach it to target ID 1 minus minus user 1. Oh, I missed IceKisi over here. So regarding these two commands, first I created an account with username user1 and password password1, and in the second command I allowed access to target ID 1 by this user. So if you want to have a look into all of your accounts that are present, it will be minus minus mode account operation show. So there is one user, the password is password1, and if you want to have a look into the targets now, mode target, so here you can see that user account 1 is attached to it. So now what is going to happen? Only desk 8 or 192.168.1.8 can log in into it or access it, and that too in case it provides the correct credentials for the user 1. So this is the dual layer of security corresponding to any target. So this is implemented at the target level, not at the LUN level. If you have multiple LUNs attached to it, you cannot isolate security for them. Effectively what you have to do is you are allowing access to a target. In case we have multiple LUNs attached to it, all the LUNs will be accessed by the machine which is allowed access to this target. Okay, so with this we have completed this part. Now for maintaining the consistency so that these LUNs are accessible even after the TGTD is rebooted, we need to modify the file /etc tgt targets.conf. Right now there is only one line which is uncommented, which says the protocol to use is IceKisi. So we need to add the details about the target 1 to this file. How do we fetch these details? TGT Admin minus minus help and minus minus dump is the option which dump these details in XML format. So I just copy it, open the configuration corresponding to targets, Shift G, move at the end, paste it, and the password we need to modify is password 1. So this is the initiator 192.168.1.8 that will be allowed access to it, that too after providing the credentials of this user. So I just save it and I restart it. Now I can see that this information is still persistent. One more thing that I need to make sure is IPtables. Here I can see that I am allowing port 21 but not everything, and so netstat minus process name, process ID or the process name, all numeric TCP whether they are listening. So grep TGT, so what it does is it tries to grep all the ports which are open or listened by the process TGTD. So we can see that it's listening on TCP port 3260. So this is required to be open for the network which is allowed to have access to this iscsi server. So let me open this. So this is the first level of security that comes. IPtables should allow it. Secondly, iscsi server ACL information should allow the IP to have access to target. And the third level is you should have a credentials to have access to that particular target. So we are done with it. chkconfig --list tgtd. So it's switched on. So just to make sure that the target has been configured properly, I am rebooting the machine to make sure that all is fine. So let the machine come up. Okay, so the machine has come up. TGT ADM -S. So we are perfect. We configured an iscsi target, we modified the configuration, we switched on the service and rebooted it. Now iscsi target server is ready and is persistent after the reboot. Coming on to the second part, which is going to be your client end, the first thing that we need to do is we need to install iscsi-initiator utils. I'm missing T. I have my repository present on CD, so the CD was not mounted and I was not able to work on it. So now I have installed the package iscsi-initiator utils. The second important thing is /etc iscsi-initiator name.iscsi. This is also an important part. Actually, I have already modified the name. So you need to make sure that the name should correspond to the same IQN format, IQN.year-month, and then reverse of your name and something after it that identifies it. Okay, so if you have a look into the files that are installed by this package rpm-ql, you see that it actually has two services associated with it, and these two services are iscsi and iscsi-d. iscsi-d is actually the service which is responsible for loading the drivers necessary for iscsi and preparing it, and iscsi is the service which is responsible for login into the remote iscsi targets. Let's try to first of all switch on the services. On. First restart iscsi-d, restart. It's failed. We can do a force start. So it succeeded. Okay, now my iscsi daemon is running. I was able to load the required drivers. Now the next target is I'm going to fetch the details from the iscsi target. So what's the IP address of our target? 123. Okay. iscsi ADM is the command that is used at the iscsi initiator end. In case you are not very familiar about it, you can make use of man. So this is basically a command line tool which allows you to discover your database from a particular IP address. Okay, let's try to understand it. First mode is discovery DB, which makes use of the database which is present locally on this machine or your client. In case it has the details about a particular portal, they will be updated. If not, the complete details will be fetched if you are moving in discover mode. So it will be able to fetch all the details from the iscsi target. Minus mode node says you are able to, or you can log in or log out of a particular target. And to list all the nodes, you can just type the command minus mode node. So node is actually your iscsi client. So the first thing that we need to do is, we don't know which are the LUNs which are present on iscsi server. We need to discover it, but the discovery will happen only for the client which is allowed to have access to it. So how did we allow access? First level through IPtables, and second level by providing ACL information, and third using user details. So iscsi ADM minus mode discovery DB 123 minus discover. So it says it is able to discover this IQN from 192.168.1.123, which is the server. So the second part is iscsi ADM as a node type send sorry so coming down now, as you have already discovered it, you need to log in into this portal. How do you log in into it? You need to use the mode node, and you need to specify the target ID and portal name where you want to log in. So copy it, replace the target name by the target name which was fetched from the iscsi server 192.168.1.123. So it says and minus login or minus L at the end. So what it says is use the target IQN, this one corresponding to disk 1, and login into the target, this one, login into this target on the portal 192.168.1.123, and it says could not log in into it. Okay, it says authorization failure because the second level of authentication which we implemented on it is to allow only user 1 to have access to it. So let's copy some details from it which says make use of CHAP authentication, and this username and password I copy it. Send targets, sorry, nodes that were discovered, authentication, authorization. Okay, so I just commented which said no authentication was required, so I'll uncomment that we need to authorize using CHAP and using the username user1 password 1. So now where did I update the details? When I did run a discovery mode on the target 123, it was able to fetch the details and fill up the database inside varlib iscsi nodes and IQ number and then default. So I did modify some details inside it now, which allows me to log in into that IceKisi server using the credentials. So what I did, I modified it to make use of session.auth.auth method chap, username user1, password password1. Now if I just try to log in into it, okay, just before login I would like to show you fdisk-l, which says uh, that I have multiple disks on it as D, A, B, C, D, E till E. So if I try to scan it once again, this should come out to be dev SDF. Now let me try to log in into it once again, and this time it is successful. So fdisk-l grep disk. Now I can see that there is one more disk which is visible and which is named as dev SDF, and the size is 200 megabytes. So now this iscsi target has exported a block device and iscsi-initiator has imported it. Now the objective is we need to format it so that it's visible and mounted after every reboot. Now the name of the block device may be different depending upon the hard disks that you have attached to it. So okay, we'll cover that static naming in different session. As of now, what we are going to do is fdisk dev sdf, and here if we see it's blank, no partition is created on it. So what we are going to do is we are going to create a new partition inside it, create a new partition primary 1 utilizing full space, and now we format it using ext3 or ext4, that doesn't matter, which is my file system, which is my operating system version. Red Hat release it's 6.3, it supports ext4, so mkfs.ext4 dev sdf1. So I formatted it. Now I'll create a new folder. Okay, that's already created. So what my objective is, every time the machine reboots or the client reboots, it should be able to mount this iscsi device over the folder iscsi. So I modified etc fs tab for it, device dev sdf1 ext4 defaults dump and fsck. Okay, so one more thing that I need to take care while mounting these iscsi devices is that they should be mounted after the networking is brought up. So there is one good option which is provided in etc fs tab is _NetDef, which says try to mount this partition after the networking is up, because till the time networking is down, iscsi device cannot be mounted. So dev sd1 sdf1 will be visible only after the networking is brought up and iscsi is restarted. So I just save it. Let me try to mount /iscsi df-h, and here I can see that iscsi is mounted, works fine. So let me try to reboot this machine and make sure that this device is available, or this device SDF1 is available and mounted every time after the desk 8 or your station is rebooted. So let's wait for the machine to come up. I think it's come up. Okay. So here you can see that your iscsi folder is mounted and is available after every reboot. The most important part is to be noted is your services iscsi and iscsi-d should be switched on. Secondly, etc fs tab should be modified to make use of NetDef, because it makes sure that the device is brought up or it's mounted after the networking is up, and your device will not be visible until the networking is up, because this is the device over the network. So the same happens for NFS. I believe I'm able to make you understand the topics regarding iscsi server that we configured on it and iscsi client that we configured on desk 8. So this is it. We can have multiple targets on iscsi target. For example, I can just create one more. Uh, okay, so every time you are creating, you need target name iqn dot 13 March in the same way you can create multiple targets. Okay, so here you see, here is target 3. This has no ACL information attached to it, so you can create an ACL corresponding to this one. You can add account information corresponding to this, and additionally you can add a backing store to it. The same happens for target 2. So in this way you can create multiple targets and it's suggested that you create only one LUN. It's technically possible that you can attach multiple LUNs to the same target, but having single LUN corresponding to a target says you can allow or you can have an ACL corresponding to every LUN. So for that you need to have a single LUN inside a single target. Every target should have a single LUN and ACLs are attached to the target. So effectively you can control every LUN to have who could have access to which LUN or backing device. I believe I should be able to make you clear about iscsi target and iscsi initiator, but still, in case you have any concern, please do comment or please update so that we can make a video for that and we can improve ourselves if we are missing something. In the next video we are going to provide a static name for these iscsi or the LUNs that we have fetched from iscsi server. Thanks for viewing the video. Have a good day.